Hi, hello there. It's me. So hi guys. I am your reporter for today. So my name is James Ryan E. Castañares, but you can call me Cons if you see me on campus when the pandemic is gone. So I am a third year student taking up Bachelor of Science in Civil Engineering, major in structural. So if you have future questions or clarifications, you can email me or chat me through my Facebook account, which is jamesryan.castañares, and also my email address, which is j.castanares.511.928 at umindanao.edu.ph. So, first up, first is we go to our quote of the day, which is provided to us by Naim Calloway. So the small steps in the right direction can turn out to be the biggest step of your life. Remember, the biggest step, even if you decide a small thing, which is just you thought that it is just a decision to make instantaneously, but that decision can result to a larger or bigger outcome that can be a positive or negative. So in life, you have to decide whether you do something or you don't care about that thing. So to us students, we can relate to this quote, especially engineering students, that every decision we make, whether we study or we play games, watch animes, that decision can affect our future. And when taking that decision, it will lead to an outcome, and that outcome will be determined from the decision that you have made. So to us future engineers, let us take up the right path and the right decision in order to achieve our dreams and goals. So next, how did you cope up during this pandemic? So this pandemic has been a very difficult time because you don't have any time or place to go to relax, to hang out with friends, to watch movies, to play games, to play sports, because everything or every place in this country has been locked down ever since the COVID-19 entered. So, in order for me to cope up during this pandemic, I have decided to do workouts. So, second is watching movies or animes or any YouTube videos that are very, very satisfying. And thirdly, sleeping and eating is very, very important to me because the pre-pandemic routine that I have done has been very, very unhealthy because I have been sleeping late at night. Next is what is my favorite color? So my favorite color is the color blue. Because ever since I was a child, I was exposed to this color every day because I have watched cartoons, Power Rangers, especially Power Rangers, because my favorite Ranger is the Blue Ranger. So next, this color can associate with me because I am a type of person that is calm, and I also love water, and also I love the sea, the ocean, and every body of water that I see because it reminds me of a calm stream or a calm water that is very peaceful and is very, very relaxing. So next question. So what are your expectations in Hydrology BCE 311 subject during the duration of class? So one of my expectations is that I will learn more about the hydrological concepts or processes that affects our future jobs, and also our surroundings. And lastly, my expectations for this subject is that it will be very, very, very fun along with our advisor. And also I expect to this subject to learn more about the random things about hydrology. So next, so we proceed to our topic for today, which is the basic probability and statistics. So we will look up on the basic probability and statistics, and only the basics. So, trivia for today. Did you know that probability was discovered when a gambler's dispute in 1654 led to the creation of a mathematical theory of probability, which the two famous French mathematicians, which are Blaise Pascal and Pierre de Fermat. So our objectives for this day is that we need to understand what statistics and probability has to do with hydrology. Next, to determine whether an event will occur or not. Number 3, determine the different probabilities that will occur or that will be involved in this topic. And lastly is to fully understand the basic concepts of statistics. So we proceed to our next slide, which gives us the essential terms needed for this topic. So first, what is statistics? So we all know that statistics are those charts, graphs, and other tables that shows the information or the data gathered, and also it helps to draw conclusions. So what is the meaning of statistics? So statistics is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data. So next, so what is this probability? So probability is concerning to the numerical descriptions of how likely an event is to happen or to occur, when the probability of an event is a number between 0 to 1. When speaking of 0 probability, the event will not happen. And when we talk about when have 1, the event will surely happen. So probability is simply how likely something is to happen. Next, basic probability. As I have mentioned earlier, probability is a numerical data or numerical assumption that something will happen or likely to happen. So basic probability, it can be expressed as proportions that ranges from 0 to 1, and it also can be expressed as percentages ranging from 0% to 100%. So we proceed to our basic probability needs, or terms needed. So when we talk about event A, it is equal to the P and A. So event A is the assumption of an event. When we talk about N, it is the number of observations. And we talk about NA, it is the values in the range of the event. So we can get the event A, which is estimated to be NA over N. So we have an example here. So the following rainfall depth were observed in the month of May over the past 10 years at the Philadelphia rain gauge. Based on the sample of the data below, estimate the probability that May's total rainfall will not exceed to 4 inches in any given year. So we have our sample data and we have our formula to get the probability. We have PA equals to NA over N. So we get to our given. So we have A, which is the limit, which is will not exceed 4 inches. And we have our N. In order to get N, we must subtract the May 1999 to May 2008, which makes 2008 minus 1999. We get 10 years. And NA, we can get NA from the month that the data has been gathered, which is January, February, March, April, and May, which is 5. So we can get our probability A. So PA equals to NA over N equals to 5 over 10, which gives us 0.5. Or we can express that to a percentage, which is 50%. So our probability or estimated probability that May's total rainfall will not exceed 4 inches in any given year is 0.5 or 50% chance that it will happen. So we proceed to our next total probability. So total probability. So if the sample space, or the one representing the whole set of space, as you can see in the figure, is completely divided into an overlapping events. In example, the A1, the A2, and the A3. So in order to get that, we must sum all the divided groups or non-overlapping events in order to get our whole set. So conditional probability. So there are two events, A and B. The overlap is the event that both occur, A intersects with B. So as you can see in the figure, the A intersects B is that the middle part of the Venn diagram, which is the both events has a common or has a interconnection with each other. So PBA is the conditional probability that event B will occur given that event A has already occurred. Therefore, the joint probability that both will occur is A and B. So we have this equation, P A and B is equals to P A intersects with B equals to P B dash A P and A. So next one, we have this figure, conditional probability. If A and B are independent events, then PA intersects with B equals to PA times the event PB. So as you can see in the figure, we have an event A and an event B, and they have both intersected at the middle, which we have A intersects with B, and whole of the set is also there, which are the conditional probability P A intersects with B is inside the whole set. So next one, complementary probability. If B is the complement to A, then event PB is equals to 1 minus event PA. So you can see in the figure, you can understand or you can analyze why the equation is 1 minus PA, because the A is inside B. So the A is taking up a area inside B, so that 1 minus event A in order to get the PB or the whole set. Next, we have an example here. The values of annual precipitation in College Station TX from 1911 to 1979 are shown in table 11.11 and plotted as time series below. What is the probability that the annual precipitation R in any given year will be less than 35 inches, greater than 45 inches, between 35 and 45 inches? So we have our given, which is the end observation or the data observation, which can be produced when subtracting 1979 to 1911, which we get 69. And we have the given 23, two conditions. We have 23 and B and 19. So in order to get our first question, so what is the probability that the annual precipitation R in any given year will be less than 35 inches? So we have event A equals to event P R less than 35.0 inches is equals to NA over N, which we have our NA is 23, which we get 23 over 69, which we get 0.33 or 33% that the probability of the annual precipitation R in a given year will be less than 35 inches. Next, we get the greater than 45 inches. So we get PB. Event PB is equals to P times precipitation R greater than 45 inches equals to NB over N, which we get 19 over 69, which is 0.28 or 28%. So there is a 28% that the annual precipitation R in any given year will be greater than 45 inches. And lastly, between 35 and 45 inches. So we get event P 35 inches less than or equal to precipitation R is less than or equal to 45 inches, which is we must get the complementary probability between the two conditions. So we get 1 minus PA minus PB, which we get 0.39 or 39 inches. So there is a 39 or 0.39 chance that the annual precipitation R in any given year will be between 35 and 45 inches. And that concludes my report. So if you have any questions or clarifications to my topic, you can contact me or email me with my contacts at the PowerPoint presentation. And that is all. Thank you.